Hello friends, welcome to one more video of CS Technology. In this video, we'll look into the Viva questions on tree data structure. So this is part 4 of this series. So let's begin. So in the previous videos, we have seen what is data structure, what are arrays, what are linked lists, what are stacks, and what are queues. So if you have not gone through those videos, I request you to go through them. So let's jump into the trees. So what is a tree? A tree is a hierarchical data structure, which means that it follows a hierarchy that consists of nodes. So each of these circles which you are seeing are nodes which are connected by edges, right? So these are the edges. It has a root node at the top and intermediate nodes in the middle and leaf nodes at the bottom, forming a branching structure. So as tree have a root and then it has branches. So this is a similar model which the tree data structure follows. So how are the main components of what are the main components of the tree data structure? The main component are nodes. Each element in a tree is called a node and contains data and references to its child node, right? So how do you represent a tree? You can represent it using a linked list, where each node is nothing but an element in the where each element is nothing but a node in the linked list, and each of the node will point to the left as well as the right. So we have gone through edge. The connection between nodes in a tree is called an edge. Root is the topmost node. Parent and child. Nodes that are connected directly are called parent and child node. Right? For example, one is the parent and two is the immediate child, the left child. Three is the right child of one. What are leaf nodes? Leaf nodes are the nodes which do not have any other child nodes. For example, 4, 5, 6, 7 in this diagram are the leaf nodes. What are some applications of trees in computer science? This is a very important question. Representing hierarchical data structures like file systems and organization hierarchies. For example, you would have noticed that in our Windows or Mac system, we generally the file system is represented in, let's say, a folder format, right? And then within that you have multiple files. For example, root is nothing but a folder. Within that you can have other folders. For example, 2 and 3 are other folders, and within that you have some files, right? So this is a very good example for which trees can be used. So implementing search algorithms like binary search, parsing expressions and representing syntax trees in compilers, storing and manipulating hierarchical data in databases and XML, implementing efficient algorithms for graph related problems, right? So now one of the most important question during your Viva or maybe even in interviews also would be, what is the difference between a binary tree and a binary search tree? So let's look in the next slide. Yeah, generally what happens is you have to picturize the tree data structure as an inverted tree, right? Where the where at the top you get the root and then you get the branches, right? Which are nothing but the nodes. And at the end you get the leaf node. So here we will discuss some key terminologies related to the tree. At the same time, we will discuss the difference between the binary tree as well as the binary search tree. So let's check with the parent. So the key terminology which the first one is the parent, right? So what is a parent? Parent is a node, right, which comes maybe at the top or maybe in the between, but which has a child. So parent and child are uh, are mentioned whenever there are two nodes. For example, 7 is the parent of 4, 4 is a child of 7, right? What are siblings? Siblings are the nodes which are at the same level. For example, 7 and 32 here are the siblings. 4, 9, 25 and 71 are the siblings. Internal nodes. What are the internal nodes? For example, in this diagram, you can see 7 and 32 are the internal nodes, right? Because they are neither root nor leaf. What are terminal nodes? Terminal nodes are the nodes which are at the end, right? So for example, 4, 9, 25, 71 are the terminal nodes. What is a subtree? Subtree is a smaller tree within the bigger tree. For example, if you see, consider this entire set of nodes, right? 7 nodes. You can see that 7, 4, 9 makes a subtree in itself. 32, 25, 71 make a subtree in itself, right? Now coming to the degree. What is the degree? Degree for a node is a number of child of that particular node. For example, the degree of 10 here is 2, which is the number of immediate child, which is 7 and 32, right? So if I add another node here directly connected to 10, then the degree will be 3, 1, 2 and 3. What is the depth? The depth starts from the root as 0, right? So for example, at root the depth is 0, then uh, at the node 32 will have the depth as 1, and the node 71 will have the depth as 2. The height, what is the height? Height starts from the leaf node. So from leaf node you have the 0th height, then 1 height, the height of 32nd node is 1, and height of the root node is 2. What is the path? So path is basically the list of edges between the nodes. For example, if I have to say what is the path to reach from root node to 4 and the node number 4, then you will say 10, 7 and 4. So this is the path, right? So having said that, there is another terminology called as level. So level starts from the root, where the root level is 0, then the next level will be the next level of the children, which is 2 and 3. This will be level 1, and this will be the last will be the level 2. Okay, so I hope you understood the key terminologies. So now let's go into the difference between binary tree and binary search tree. So the main difference between binary tree and binary search tree is that binary search tree has a very specific condition, right? So what is a binary tree first of all? So binary tree is a tree where each node will have must have only two children, right? One left and one right. So for example, you can see that apart from leaf node, all the nodes here, right, whether it is 1, 2 and 3, each of them have only two nodes. So that's why it is called as binary tree. Okay. Then what is binary search tree? If you notice that each node here, right, in the binary search tree, the left child or the left set of nodes is always have a smaller value than the root node, and then the right value or the node which is on the right side will have a greater value than the root node. What it means is, if you can see that the value 10 is greater than 7 but lesser than 32, the value 7 is greater than 4 but lesser than 9, the value 32 is greater than 25 but lesser than 71. So these are very important aspect of the binary search tree. So the AVL tree, red black tree, these things mostly would not be asked in the Viva. It may be asked, but these things will be covered in another video. So one very important topic when it comes to trees is the traversal. So how do you traverse a tree? So in this section, we will see how do we traverse a tree. So there are three types of traversal. First, let's begin with in order traversal. The way we traverse here is, first we visit the left node, then the root, and then the right node. So to begin with, the first will be fourth node, then we have to visit the root, which is second, then we have to visit the right node, which is 5. So by this, the entire left portion is completed, right? So now we have to visit the root node, which is 1. Then we have to proceed with the right branch, which is 3, 6 and 7. But when we visit 3, again we need to ensure that whether there are any left nodes for 3. If so, we need to register them. So which means it will be 6, then 3, and then 7. I hope you got the idea. Each time we have to check whether there are any left node for any given node. If yes, we have to traverse them till we reach the root node. Then we need to traverse the right, and for each node we need to again satisfy whether there is any left node. If so, we again need to traverse. That's how we started from 1, then visited 4, then since 4 doesn't have any left node, we come back to 2, then 5, and then 5 again doesn't have any left or right, then again we go back to 2. Since we have already mentioned 2, then we go back to the root. So this is how we traverse. Similarly, let's check what is the pre-order traversal. So for pre-order traversal, the format is root, left and right. What it means is that first we need to register the root at every place, then we visit the left side, then we visit the right side. So to begin with, we'll go ahead with root, which is nothing but 1, then followed up with the left child. See, since we go to we visit the root node, then we have to visit the left, and then again left we have to visit the second itself, because that itself is the root. Then again we need to visit the left node, which is 4. Then we have to move towards the right, because it is root, left, right. So root, left and right. So the right here is 5. We go ahead with 5. So if you notice, we have finished root, we have finished the left. So we have finished root, finished left. Then we need to visit right. So we traverse to the right node. So here again, take a pause and just comment in the section which one do you feel the next node should be printed, whether it is 3 or 6. So it will be 3 because we have to print the root, then 6 because we have to print the left, and then again 7 because that is the right node. So in this way we will complete the pre-order traversal. So just keep this in mind that always pre-order traversal, the first will be root and the last will be the right node. So in similar way, let's go ahead with the post-order traversal. So in post-order traversal, first will be left node, next will be right node, and then the last will be the root node. So if you want to try it out, take a pause and then check this out how you can implement the post-order traversal, and then continue the video. So let's begin. First you need to visit the leftmost node. So you have to always start from root. Okay, you visit, so you can check that okay whether there is any node at the left. Yes, load node number 2. Then again come back, check whether there is any node in the left. Yes. So the first node which you will print is 4, right? Then you have to check whether there are any right nodes. Are there any right nodes? Yes, which is 5. Then you have to print the root node. So left, right, root, left, right and root, which will be 2. Then in this manner you have completed the left part of the tree. Now again you have to go to the root. But will you print the root? No, because you have to traverse towards the right side of the tree, right? So you traverse to the right, which means you come to the third node. But will you print the third node? No, because you have to again traverse the left. At each node you need to satisfy this condition, right? So at third level you will come back and then you will print 6, 7 because that's the right, and then the root 3. And then once you have completed left, right, then you need to complete the root, which means left, right subtree, and then you come back to the root. So let's see how it happens. After 2, we go ahead with 6, then 7, then go to the root 3, and then at the end the main root, which is 1. So I hope you got the idea of the tree traversal. So this is a very good example of queues, for which I have shared the link in the comment section, as well as you can see on the right side top. So please refer the video. So I hope so far you liked the video. If so, please like, share and subscribe the video. Share it with your friends. Thank you.